everybody. On this assignment, we're going to have some practice with the 7 main postulates of geometry. With numbers 1 through 6 here, we're going to answer the statement is it true always, sometimes, or never? And we're going to use those 7 statements to answer those. I'll bring that up here in a minute. We can see them off to the side here. We'll display those here in just a little bit. For number 1, a line contains exactly 1 point. That's never true, because you need at least 2 points to make a line. For number 2, non-collinear points R, S, and T are contained in exactly one plane. That is sometimes true. Okay, somewhat just depends on the situation. Maybe you're talking about 2 points in one plane and 2 in another, and 1 in another. It just depends. You can definitely make the argument for the 3 points non-collinear or in a plane, but it just depends on your drawing, your situation, whatever the case may be. For number 3, any 2 lines L and M intersect. That is true sometimes. The lines could be parallel, or if they're not parallel and they're in the same plane, they would intersect at a point. Number 4, if points G and H are contained in M, then GH is perpendicular to plane M. Okay, no, that's never going to happen. If you have 2 points in a plane, they're going to make a line on that plane. It won't be perpendicular unless you reference that it's on a different plane. For number 5, R and S, planes R and S intersect at point T. That is never true. The reason it's never true is because 2 planes intersect in a line, not a point. Number 6, if points A, B, and C are collinear, then the segments AB, BC, and CA are contained in exactly one plane. That's going to be always true, because if I have 3 points in a plane, I can connect those 3 points, any 2 of them at a time, to make a segment, which they're saying right here, AB, BC, and CA. So because the points are in the plane, the 3 segments will also always be in the plane. Alright, for number 7 and 8, we need to reference our 7 postulates. Here they are written in red here, and we're going to use that to address which postulates match up with these statements in the picture. In the figure, AC and DE are in plane Q. AC is parallel to DE. State the postulate that can be used to show each statement is true. Okay, well, these could have several answers. I'm going to reference them by saying statement 1, 2, 3, 4, 5, 6, or 7, or more than 1. Let's look at the number 7. Says exactly one plane contains the points F, B, and E. Now it's not on plane Q. It's not referencing that. It's just saying that we have these 3 points. They could be contained in a plane. Okay, so that looks like it would go with statement 2 up above, and then also statement 4 works as well. They reference the situation that they're talking about. For number 8, BE lies in plane Q. Well, yeah, B and points B and E, notice they're not connected here in a line, but that's not to say we couldn't connect those with the line, like I will right there. And so several statements could work. Number 1, through any 2 points there's exactly one line. Number 3, a line contains at least 2 points. That works. If number 5 could probably work. If 2 points lie in a plane, then the line containing those points lies in the plane. So yeah, several of these postulates work with the given situation.